Until today's video, we have covered most of the construction process of our building, Antwerp Porthouse. We went over all the way from the most bottom to the highest point of our building. Today, we will go over the last process, finish of Antwerp Porthouse. It will include the Antwerp Porthouse's flooring and facade design and system. First, let us go through how floor was constructed in our main superstructure that floats above the ground. Before constructing the floor, there were three main challenges that the contractor had to face, as the 1,500 tons of superstructure is floating above the ground with only few pillars supporting its weight. To solve those challenges, contractor focused on the weight being free of temporary propping and speed and ease of the construction. As the superstructure itself was already a heavy structure, contractor focused on using the floor panel that has a low floor self-weight, which was important in order to limit the weight of the new building floating above the existing building. In the process of creating a floor, a temporary propping is used to properly shape the floor and withstand the concrete to not collapse until it is hardened. However, the contractor wanted to reduce any unnecessary weight in a process of constructing the floor. Therefore, the contractor looked for floor panels that could achieve long spans and the load requirements with no need for temporary propping. And in final, contractor searched for a flooring system that needed low concrete volume and in speed of construction, but high simplicity in constructing the floor. All three elements were focused on spending lowest amount of weight possible in the flooring. To satisfy all three elements, Tata Steel Construction Company's ComFloor 80 and 60 were perfect composite floor deck system. ComFloor 80 and 60 are the steel floor deck that are used in flooring in the Antwerp Porthouse, and the number that is at the end of the name presents the deepness in millimeter of the trapezoidal profile that gives an ability for long spans. Using these two composite floor deck systems, there is an exceptional resistance to compressive buckling that could possibly be created by the concrete and reduce the number of secondary beams to withhold the deck. Through these two floor decks, the contractor of Antwerp Porthouse was able to solve challenges with the benefits, which are long span, low concrete usage, low weight of the deck itself, and less beams needed to support the decks. This is the image we designed of how the floor of Antwerp Porthouse is composed. It is composed of ComFloor and the wire mesh and the concrete, with the H-beam below. ComFloor is placed above the H-beam, pinned with shear connector. Then, wire mesh, which is a steel, is placed above the ComFloor for the reinforcement. And concrete is poured and created reinforced concrete floor panel. This process is followed on each floor for the whole superstructure. Till now, we have covered how floor construction took place in our building, Antwerp Porthouse. And now, we will go over how the facade was constructed.
Every side of the superstructure is covered with glass panels. The extreme geometries and parametric detailing of structure have created aesthetic factors in Hadid's work, pointing the due south toward the city's historic riverside and center. It seems both frozen in motion and surging forward. The top's triangulated glazed cladding starts off flush at the prow but erupts into irregular projections, becoming increasingly crystalline along its length, which is a reference to Antwerp's famous diamond trade. The extension is covered in triangular facets. There are some transparent and others rippling texture that echoes the water at the north. Workers of the Antwerp Porthouse installed pre-made glass panels at the construction site, connecting them to the superstructure with the bracket and bolt elements. Separate triangle panels connected in a bundle with the same method and lifted to the superstructure's outer wall by a crane. By this method, superstructure's outer wall was completely filled with the glass panels from forward to the backward. The facade panels of the building contain a mix of transparent and reflective glass triangles. The alternating transparent and opaque panels are intended to visually break up the scale of the structure. They also provide ample daylight, shade, and views out to the Scheldt River, city, and port for workers. The new extension appears as a carefully cut form which changes its appearance with the shifting intensity of daylight. Like the ripples on the surface of the water in the surrounding port, the new facade reflects changing light conditions. The superstructure is wrapped in an aluminum-framed glazed cladding system, which reduces solar gain. The facade of the new extension consists of Saint-Gobain Cool Light KS147 glazing. This modern noise control glazing allows keeping intrusive noise out, providing the tranquility essential for working and living, a benefit that was needed for the porthouse that combined it with the solar control glazing from the Cool Light range for providing multifunctional glazing options. When you are looking at the outside of the porthouse, you will notice that you can't see the floors, or the columns, or even the pipework. Well, that's because building was designed for us not to see those things. Spandrel glass was used to prevent materials or construction elements from being viewed from the exterior of a building. Spandrel glass is the glass that lives in between the floors that is made just like the other units, often with the same glass, but has a special coating or treatment to the back that prevent us from looking at it. Glass fabricators have different options and products available to them when they are making the spandrel glass. One of the most common, as seen here, is applying a silicone spray to the back of the units. Spandrel glass can be designed to blend with the building, or it can be used to add a really cool look to the building, but in the end, it's intended to hide all the not so pretty stuffs. And here's the beauty of it. Because these units will never be visible or have lights behind them, they get away with a lot more flows than any other units. Saint-Gobain provided insulated spandrel silk screen, the enamel with 0% of lead. Saint-Gobain products contributed to the certification BREEAM Very Good the product obtained, which means the product was very eco-friendly.